we will discuss a very familiar model in the GRE exam, namely quantity comparison model. So in quantity comparison model, you will have the two quantities, namely quantity A and quantity B. What we need to do is, we need to compare those two quantities and we have to elect the answer out of the four option choices. You will find the option choices as quantity A is greater and quantity B is greater, and both quantities are equal and relationship cannot be determined. These are the fixed option choices you will find for any kind of quantity comparison model. So let me discuss a very simple example problem which is based on quantity comparison. So here he just mentioned the information as ABCDEF is a regular polygon, and he said that AB is having the side length as 5, and quantity A is the ratio of area of ACE divided by the ratio of area of ABCDEF. So we need to find out the area of ACE and the area of ABCDEF, and we need to find out the ratio of those two, and quantity B is given as 2 by 5. Remember, don't try to use the calculations as finding the area of a triangle and finding the area of a hexagon and all. The logic behind the problems which are based on ratios of two figures, you just blindly use a very simple logic over there. Understand the symmetry of the geometry figures. If you are able to split the given question or cut the figure into any unique parts, you can solve the problem very easily. Suppose I have a square as like this, and I can split this square into 4 equal parts, and if he is asking me to find out the area of this figure with the entire square, I can say that that's a quarter part. So instead of doing like that, I am just using a very simple logic. After making into unique cuts, just count them 1 1 1 1. This is nothing but this is 1 out of 4 parts. This is going to give you a ratio. In the similar manner, I am trying to use the same logic here. So this is a hexagon. I am trying to split this hexagon into 3 equal parts initially. So splitting this hexagon as like this. Take the hexagon as like this, and I am trying to split this hexagon into 3 equal parts. 2 equal parts I can just cut into middle, but to make into 3 equal parts, you just use the cuts as like this. So now you are able to make this into 3 equal parts. Again, what I am trying to do is, I am trying to split it into 2 individual parts for everything. So now my entire hexagon is split into 6 equal parts. So you can just make the count over there as like this. So this is the equal parts you made. So just count them 1 1 1 1 1 and 1. All these are unique parts, so definitely these all 6 parts are having the equal area. So he is asking the area of ACE. ACE is nothing but this part. This part is having 3 parts. 3 parts is nothing but I am just taking the area of ACE as 3. And what is ABCDEF? ABCDEF is nothing but total hexagon. Hexagon 1 2 3 4 5 6. Total 6 parts we are having. So ratio of this figure is nothing but 3 by 6. Take any dimensions, you will get the ratio as 3 by 6 only. That's the logic behind the problems of ratios of two areas. So I got the quantity A as 3 by 6 and quantity B is given as 2 by 5. So you need to compare these two. So comparison of these two will be very simple. So you just try to use the cross multiplication method here. 3 into 5 is 15 and 6 into 2 is 12. 15 is greater than 12. You can blindly say that 3 by 6 is a higher quantity than 2 by 5. So you just elect the answer choice as quantity